In today's notes, we're going to look at direct, inverse, and joint variation. You have definitely seen direct variation before in Algebra 1. It was around the time you were learning about linear functions. Direct variation should have been taught. I'm still going to go through and refresh your memory as to what direct variation is and what it means, but I want you to understand that you should have seen this before. So let's go ahead and start with the refresher, which is direct variation. Any function can be written in the form y equals kx. Let me actually just highlight the formula, y equals kx, where k is a non-zero constant, and it is called a direct variation. So this formula that I just highlighted, y equals kx, that's your direct variation formula. By having that notation where it says k is a non-zero constant, that just means that this k value here can't be zero. It could be -1, -1/3, +1, +1/3. It can be any value except for zero. And the last thing that I want to highlight is that the constant of variation is k. So remember, you should have learned this back in Algebra 1 with linear functions. So this is very similarly in the form of y equals mx plus b. The only difference is you don't have a b here, and that's how I tell my students in Algebra 1. The way you know you have a direct variation is because the b value, which is usually your y-intercept, is 0. The m is very similar to your k value. It's very similar to your slope. So whenever you're looking at that constant of variation, you can think of it as a slope of sorts. There's one other thing I want to mention. This y equals kx formula, it says it can be used for any function. Well, that kind of bothers me a bit because you can't use it for any question I give you. It's only specific questions. So whenever you see this notation that we're about to write, this is when you can use a direct variation equation. When you see y varies directly with x, that's a kind of slap in the face that, hey, you need to use that y equals kx formula. This is specifically when you're going to see it. So when you have y varies directly, that's your kind of indication that you're going to have y equals k. And since you're varying it directly with x, you're going to multiply it by x. So that's why we just write it as y equals kx together. So we're going to go ahead and look at a few steps, and then we're going to go ahead and do a couple questions. So the steps that we're going to do in order to find our constant of variation are these three guys here. We're going to translate our problem into the algebraic statement, into y equals kx form. We're going to substitute the x and the y for your known values, and we're going to solve for k. You've seen this before, guys. It's back in Algebra 1, so it's a lot of refreshing your memory as to what you've previously seen. The last thing is if you're finding additional values, so if it actually has you find a specific value. Whenever you do that, you're going to replace the k value that you just solved for in the last question, and you're going to substitute it into the y equals kx form. You're going to, again, substitute the value that was given for one of the variables, and then solve for the other variable, the one that's missing. So all of these steps are honestly what we're going to use for almost every question that we see on this first page. I will mention, as I get number 1 situated, you definitely want to have a scientific calculator next to you. It's not required, but for some of the questions that we do, it will be useful. So if you need to pause the video and grab a scientific calculator or pull one up on your computer screen, that's completely fine. Okay, so let's look at example 1. So in example 1, it says the circumference of a circle varies directly as its diameter. Find the constant of variation when the circumference is 22 centimeters and the diameter is 7 centimeters. Okay, even though it doesn't have the direct translation like we have here where y varies directly with x, it has the same information, that's specifically that directly part. So I'm going to underline and kind of write out the things that I need for this. So it says the circumference, so that's C. We're going to label the circumference as C. The circumference of a circle varies directly as. Most of the time you should see with, but directly as for some reason is another way that they write it. For me, when I read it, it sounds weird, but it's still going to be acceptable for making it C equals K times some value. So in this case, especially since we have the diameter behind it, we're going to multiply it by D. So remember, when we were translating this piece up here, the y varies directly was that y equals K. And that with x, whatever you're going to have behind it, that's usually what you're multiplying with. So that's what we're going to create. So that formula that we have for that first question is C equals K times D. And you can put the little multiplication in the middle if you need to. So let's go ahead and look at the second part. The second part says, find the constant of variation when the circumference is 22 centimeters and the diameter is 7 centimeters. Okay, well, based on the directions that we set out on the top, when we were finding the constant of variation, the first thing we had to do was translate, and that's literally what we just did down here. The next step says, substitute the x and y for the known values. Well, even though these aren't exactly x and y, the c value that we do have is going to be 22, and the d value that we have is 7. So we can take both of those values and substitute it in to find your constant of variation. So we're going to make this 22 equals k times 7, and then we'll have to solve for k, which is the last step, solve for k. So I'm going to divide both sides by 7 here. So k is going to equal to 22 over 7. That's my constant of variation. Remember, k is acting as your slope, but it's technically called your constant of variation. We highlighted that at the very beginning. So down here, for my constant of variation, I'm going to say that that is 22 over 7. Okay, part B is over the exact same question, and this one says, find the circumference of the circle when the diameter is 21 centimeters long. Use the constant of variation formula that was found in the part A above. So literally, we're going to take this formula, and I should probably actually write out my formula for part A, using that k value that we just found. So our new equation is going to be c equals the k value, which is 22 over 7, times d instead of x. So times d. And you don't have to keep putting that multiplication symbol. I'm just putting it so you know the operation between it is multiplication. So let me rewrite it. And I'm going to follow these steps down here because remember, you're finding an additional value for your variable. It specifically said find the circumference, so I need to find c when the diameter is 21 centimeters long. So based on this, I'm going to replace my k value, which is what we just did. That was this part. Now we're going to substitute the value that was given for one of the variables, and then we're going to solve for the other. So literally plug this in. This is just back to Algebra 1. So we're going to take 22 over 7 and multiply it by 21. I would definitely want to multiply this out. However, 22 times 21 over 7. If I have to multiply 22 times 21, I'm definitely going to have to use a calculator. And let's say you didn't have one. I know you probably do have one next to you, but let's say you didn't. We can definitely take, since we're going to divide both of these, we can take 21 and 7 and reduce it. So if I take 21 and 7 and reduce it, that's going to give me 3. So I really just have 22 times 3, which is going to give me a circumference of 66. That should be my answer. So at the bottom, my circumference is going to be 66 centimeters when your diameter is 21. Okay, looking at C and D. C and D are not related to A and B, so these are two completely different. They're completely different from the last one. C and D are related, so if you want to, pause the video right now and try to see if you can do C and D on your own. Okay, let's look to see what you have for C. So first thing we need to make sure is that we have a direct variation. So this says y varies directly as the cube of x. Okay, when I see that word directly, it's probably going to be a direct variation. So we're going to write this as y varies directly as, that means equals k times the cube of x. Okay, well, how would you write the cube of x? We would need to take x and then cube it. That's it, x cubed. That's my equation. So let's write this out. We can make this y equals k times x cubed. The rest of the question says, find the constant of variation when y equals 9 and x equals 3. Okay, so we're going to take, just like we did before, y equals 9, x equals 3, and we're going to substitute it in. So we're going to take y equals 9, k times x equals 3 cubed. 3 cubed is 27. I'm going to have to divide both sides by 27. So we're going to have k is going to equal 9 over 27, which will simplify to 1 over 3 because they're both divisible by 9. That's my k value. That's my constant of variation. Since I know, and especially since I kind of read ahead a bit, it says use a constant of variation for C. Let's go ahead and write the equation for this. So using this form that we just had, I'm going to write my equation over here as y equals k, which is now 1/3 x to the third power. This is my equation. Okay, well, using that equation, it says find x when y is 8, and use a constant of variation from C above, which is the question we just did. So down here in green, I'm going to rewrite y equals 1/3 x to the third power, and we're going to go ahead and plug in our values to find our answer. Well, if I'm finding x and I need to plug in 8 for y, I'm going to make this 1/3 x to the third power. I need to isolate x. Okay, well, think about PEMDAS. We're going to have to do kind of inverse or backwards PEMDAS, going from the bottom up, so starting with the adding and subtracting, then multiplying and dividing, and eventually work our way up to exponents before we can actually get x completely by itself. You should remember how to solve this back from, honestly, even Algebra 2, but what I could definitely do with this is make this one big fraction so it actually looks a lot nicer. So I'm going to make this 8 equals, we're going to put x cubed over 3. Because, and I'm going to actually push this up just a bit, it's going to shoot back down, so make sure that you write that out. Whenever you have that, you want to make sure that you understand that x to the third power will be in your numerator, because that x to the third power is over 1. So just put all of it in your numerator. That x to the third power, put it in the top. So up here, I'm going to multiply both sides by 3. So we're going to have 24 is going to equal x cubed. And in order to get rid of something that is already being cubed, we're going to cube root 24. So I'm going to make this x is going to equal the cube root of 24. Technically, you do have a calculator, so we can use our calculator to check it, but you could definitely write this as a simplified radical, because if I try to plug in, and I'm doing it in my calculator right now, the cube root of 24, it gives me an ugly decimal. It's like 2.8. I don't like it. So instead, I want you guys to simplify your radical. Let's see if you guys remember how to do this. So over here, I'm going to rewrite the cube root of 24, and I'm going to split up 24 into nothing but prime numbers. So I can break this into 2 and 12. 12 can be broken into 6 and 2, which breaks into 3 and 2. So underneath this cube root, I'm going to rewrite 2 times 2 times 2 times 3. If you guys remember when we were simplifying radicals, this index tells you how many of the same number you can group together. I can group all of these 2's together because they're 3 2's, that's the index, and I can help them escape from this little radical prison they're in. Only one from every group that I ever make from these radicals will make it out. So only one from this group. If there were 2 groups of numbers, then only one from each group would make it out. But that's going back to what you guys should already know. So if I was to simplify this, I would have 2 cube root of 3. So I'm going to rewrite this as 2 cube root of 3. That's my x value. So when y is equal to 8, your x value is going to be 2 cube root of 3. You could write the decimal, but I'm telling you now, on tests and quizzes, I'm probably going to want the simplified radical form. Let's go ahead and look at the next page. For the direct variation word problems at the top, I'm going to look at question number 1. And if you guys have time, you can definitely do question number 2. So for example, number 1, this one says the distance a car travels varies directly as the time. Find the constant of variation if the car travels 204 miles in 3 hours. Use the constant of variation to find how long it takes the car to travel 34 miles. There's a lot of stuff that's being asked right now. Well, the first thing that is being asked is to find the constant of variation. And then it's also asking for me to use that variation, so use that constant of variation to find out how long it takes for us to travel 34 miles. Okay, let's go ahead and write an equation for this first sentence, because that's going to be the meat and potatoes of this problem. So this says the distance the car travels, so we'll say d, it varies directly as, so that means equals k times, and I can actually write that above so you can see it, equals k times the time, which is t. So the formula that I should have is d equals t k times t. Let me write that correctly. That's my equation. So in this equation, we need to do step 1, which is to use or find the constant of variation if your car travels 204 miles in 3 hours. Well, 204 miles, that's a distance. And 3 hours, that's a time. Take d and t, plug it in. So we're going to make this 204 is going to equal k times 3. I'm going to divide both sides by 3. And I don't know that in the back of my head. 204 divided by 3 is going to give me 68. That's my k value. So my equation that I need to use is d equals 68 times t. That's the equation that they want. So for the first part, when it says find the constant of variation, that's the constant of variation. Even though it didn't ask for the actual formula, I still have that written here because I am going to use it for the next question. It specifically said, use the constant of variation to find out how long it'll take to travel 34 miles. So right underneath it for step 2, let's go ahead and find how long it's going to take. How long is a time? So you need to solve for the time. So we're going to take d equals 68t, and I'm going to plug in the distance that was traveled, which is 34 miles. We're going to divide both sides by 68, and t is going to give me 34 divided by 68. That's 0.5, so that's 1/2. So if I wanted to write this out in words, especially since this is per hour, or 3 hours that we were talking about at the beginning, half of an hour is 30 minutes. So I'm going to write out that this is 30 minutes. And I'm going to put that as equal to my time. So for tests and quizzes, I probably wouldn't 100% put my 1/2 because, especially since the problem is asking for it in hours, I want to make sure that my answer has that hour in it. So have it for 30 minutes. This would be your answer. If you choose to do example 2 right next to it, you definitely can. However, I will post the answers for this online so that way you can check your work and your answers later on. All of this is about direct variation, so make sure you pause the video now, flip back, and make sure you understand everything I just went through. So let's go ahead and look at inverse variation. This is the next type. So for inverse variation, it says any function can be written in the form y equals k over x, where k is a non-zero constant, is called an inverse variation. So it has that same rule where that k value, that numerator, cannot be 0. It could be any other number, -1, +1, -1/2, +1/2. It could be any value, but it just cannot be 0. The k value, again, is acting as your constant of variation. This isn't necessarily similar to linear functions. This is more of a rational type function because your x, which is your unknown, is in your denominator. So it's no longer, that k value is no longer acting as a slope. It's acting as kind of like a factor that is going to be changed. So it's not going to really have that slope kind of attribute that goes with it. Another way that you're going to hear inverse variation is indirect variation. So inverse and indirect variation are the exact same thing. So if I say on a test or quiz indirect, don't think that this is brand new. It's the exact same thing as inverse. So with these questions, the main thing that we're going to look for is we're going to see the exact same kind of abbreviation that we saw before. The only difference is we're now going to see the words inverse or indirectly instead. So let's look at the very first question. The volume of gas at a constant temperature varies inversely as the pressure. Find the constant of variation when the volume is 15 cubic centimeters at 25 pounds of pressure. Okay, that very first sentence. The volume of gas at a constant temperature varies inversely as the pressure. This little part that I'm underlining right now in blue, varies inversely, is your kind of slap in the face that you have an inverse or indirect variation. Remember, unlike direct variation, we're now dividing, so we're not going to multiply. So when I see that varies inversely, instead of putting equals k times, I'm going to put equals k divided by, because I'm going to have to divide something. So let me look at the actual problem. The first part was saying the volume at a constant temperature, so we're going to say V is for the volume, equals k divided by that pressure. So we're going to use P for pressure. So the formula that I have is going to be V equals K divided by P. And we could do it as K divided by P. That's a division sign by P. But I like to have it as an actual fraction because it makes it easier. This is our equation. Let's go ahead and use the other pieces of information that were given in the question to finish the problem. So it says find the constant of variation, that's the K value, when the volume is 15 and the pressure is 25 pounds. This is what we're solving. If you look at this, don't panic and say, oh, Ms. Tapia, I don't know what to do. There's two things you can do. You can multiply both sides by 25, or you can put this 15 over 1 and then cross multiply. I'm going to put this 15 over 1 and then cross multiply because I want you guys to remember that you can always use these strategies in your future classes and my current class. So 15 times 25, I don't know that in the back of my head, so let me plug this in. It's going to give me 375. So my constant of variation is 375. The last thing I'm going to write out is my equation, 375 all over P. That's my inverse or indirect variation equation. Using this equation, just like we did before on the first page, find the pressure when the volume is 125 cubic centimeters. Use a constant of variation from above. So we're going to use the formula V equals 375 all over P. Well, since the volume is 125, I'm going to plug that in, 375 over P. We're going to go ahead and solve. And in order to solve this, I'm going to cross multiply. So we're going to make this 1 times 375, which is 375, equals 125 times P. And like I would normally do, I'm going to divide both sides by 125. So my P value is going to be 375 divided by 125. It's going to be 3. So we have, it looks like 3 pounds of pressure for this question. That's my answer. When you're ready, let's go ahead and flip to the next page. We have a word problem we're going to look at. For this word problem, you can definitely pause the video and try it on your own, but in a second I will do it. The problem says, y varies inversely as the square of x. Find the constant of variation at y equals 5 when x equals 2, and use that constant of variation to find y when x equals 10. There's two things we're finding. The first thing is the constant of variation. The second thing is the y value when x is 10. So let's go ahead and look at the very first sentence. This is the meat and potatoes of this question. Y varies, okay, so y varies inversely as, that's k equals k divided by the square of x. So I need to do x and then square it. Okay, I know it's in gray and I know it's a little small, but I'm going to rewrite it. Y is going to equal k divided by x squared. That's my equation. From here, I'm going to do steps 1 and 2. So for step 1, I need to find the constant of variation using these two values. So my y value is 5. K over x squared, which is 2 squared. This is what I need to solve. So we're going to make this 5 equals k over 4. And you can definitely cross multiply this. I'm going to multiply both sides by 4 to make sure you get experience with all ways of solving. And this will give you 20, which equals k. So that first answer that I was looking for, the constant of variation, that's 20. Okay, well, I can write my equation for this. Y equals 20 over x squared, because that's my kind of formula that I can use. And now I can actually do step 2. In step 2, this is asking me to use that constant of variation, so y equals 20 over x squared, and we need to find y when x equals 10. So 20 over 10 squared. 10 squared is going to give me 100. There's a few ways I could do this. You can simplify this without a calculator. These zeros are going to cancel. So 2 over 10, I can just reduce that to make it 1 over 5. That's my y value. Those are my two things when it asks for you to find y and for you to find that constant of variation. Those are your answers. Pretty simple, right? All these things are very basic, just asking you to pick out the little pieces based on what has kind of been written out. Okay, let's take a second and look at the last piece of this, which is joint and technically combined variation. So for a joint variation, this is a direct variation relating more than two variables with the same constant. So for instance, if you had these two items, y equals k times x times z, or if you had v equals k times h times r squared. So if you see something that is pretty much in your direction saying, hey, you're going to be multiplying two things, that's what it means to have a joint variation. Okay, I know you're like, wait, what are you talking about, Miss Tapia? Okay, let's write something out. So use purple. I'm going to write out a sample scenario you might see for this. So for V equals K times H times R squared, you might see it written as the volume is jointly related to the height and the radius squared. That is supposed to say radius. Something like that. What this is telling you is you're relating it jointly. Jointly means you need to multiply your variables. So especially since it's a direct variation, you know you're multiplying. And then from there, you need to multiply the two things that are following it, the height and the radius. And this radius specifically is being squared, not the height. So keeping that in mind, let's look at example A. I know you're like, wait, Ms. Tapia, you forgot combine. No, I didn't. I remembered it. Let's go ahead and look at number A, letter A. So for letter A, it says z varies jointly as y and the cube of z. Okay, well, if you see that, we see that part that says varies jointly. That's kind of a slap in the face that you have a direct variation that's being jointly looked at, and you want to make sure that you multiply both of them. So for this one, I'm going to write this out as equals k times, because we're going to multiply. We're going to do z, and that word jointly means you probably are going to have two or probably two, more than likely, variables that are going to be multiplied. Well, the other variables are just y and the cube of z. Well, the cube of z means you're going to do z cubed. So if I was to write this out, I'm going to make this z equals k times y times z cubed. That would be your answer. So before we do the last question, which is the combined variation, try letter C right now. Okay, for combined variation. For combined variation, it says a combined variation is a combination of a direct and an inverse or indirect variation, relating more than two variables with the same constant. So it's very similar to what we just talked about. The only difference is we're now including inverse and direct variation, which means some of them are going to be multiplying, some of them are going to be dividing. So you're going to see things that look just like this. So if you have H equals K times V over W, notice that the division sign is going to be associated with W, and the multiplication needs to be associated with V. Same thing with this one here. Y equals K times W times Z all over X. Remember, this X is probably going to have an inverse variation or indirect variation because it's dividing, and that W and Z is probably going to be have a direct variation. So you're going to kind of relate that directly. So let me give you a sample kind of written explanation or written problem that you might see. And I'm going to use this first one here. So for this equation, if you were going to write out some kind of word or problem with this, I would probably write this as the height, H is going to be for the height, varies directly with the volume and, well, remember, we have to divide that W. Let's say we're going to indirectly look at your width. We'll say W is the width. Indirectly with the width. Remember, guys, I'm not saying width two times. I don't know if you can hear, like, when I say D in width. You probably can't because I can't even hear myself say it. But make sure you read it and you understand what I'm saying. Indirectly with the width. Man, that sounds weird. Okay. So with that said, let's go ahead and look at example B and try to figure out what this is going to look like. So I'll do this one with you, and then you guys will try letter D on your own. So for letter B, it says A varies directly as B and inversely as the square of C. Okay, varies directly as, that's a slap in the face that you have equals K times. So we're going to have A equals K times B. And inversely means you're going to need to divide by the square of C. So we're going to do C squared. Okay, well, I already have the B value being multiplied by K. I can't put another K. You only have, and if you look at both of these, you only have one K value. It's right there. You can't have multiple Ks. So we're going to write this out as A equals K times B divided by C squared. That's your answer. Right now, try letter D. After you try D, I will give you the answers to C and D. For letter C, you should have gotten T equals K times V times P, so KVP. And then for letter D, you should have had X equals K square root of Y all over Z. That should have been your answer. Let's look at example 4. In example 4, this one says if V varies jointly as B and H, and V is 20, when B equals 5 and H equals 2, find V when B is 25 and H equals 4. Okay, couple things that we're doing. First thing we need to do is, of course, rewrite the problem that I have right here. I need to rewrite the formula. The next step is going to definitely be finding that K value. So step 1 I'll put is to find K. And then step 2 is to find V. Okay, so let me write the formula that I have. V varies jointly. Okay, let me think back at the top without scrolling. Varies jointly means you need to write this as equals K times. You're probably going to have to multiply these. Varies jointly as B and H. So both of those need to be multiplied with K. So I'm going to write that out. V equals K times B times H. Okay, step 1, the actual step 1 from the problem that I need to solve. We first need to find K. We're going to take our V, plug it in, take B, plug that in too. That is 5, not a 2. And then take H and plug that in. We're going to simplify and solve, so that'll give me 10K. So K will equal 2. Because the zeros here, just cancel. So that's my K value. When it said for the first part, for find K, that's the first part. I'm going to write my formula, which is V equals 2BH. And now I can actually find part 2. Part 2 says find V when B is 25, H is 4. Okay, well, we're just going to multiply. 25 times 2 is going to give me 50, and 50 times 4 is going to give me 200. That's my answer. That's all you're doing. So the only thing you need to kind of keep track of is which of these processes are you going to use? You're going to multiply these? Are you going to divide these? How are you going to separate them? So if you can understand that, we should be good. We're going to go ahead and look at the next page. On the next page, I've tried to make this kind of like a summary to make sure that you understand exactly what you're supposed to be doing. It gives you all of your kind of directions. It gives you some little hints and tricks. I kind of designed it to give you right before your tests and quizzes. If you want to kind of review something really quickly, this will definitely help. As much as I would love to do every single question here, it's not going to help you guys learn. So I'm going to do 2 questions with you, and you guys can do the rest of them on your own. I'll do with you guys number 1 and number 3. I know you don't have much space, so right now I want you to flip the paper over, try examples 1 and 3 since it's already paused on this page, and I want you guys to try it before I do it. After you try it, see if you got the same answer as me. Give it a try first before you completely give up. Okay, for question 1, I'm not going to lie, guys. I can kind of cheat because on my iPad I can zoom in, so I can make as much space as I need. So I'm going to use that kind of cheat to do the questions with you guys. So this question says for number 1, the amount of chlorine needed varies directly as the size of the swimming pool. This should have been a direct variation. This is a DV, a direct variation. So since it says varies directly as, I'm going to put equals K times. And especially since it's the size of the swimming pool, I'll just use P for the swimming pool size, and the amount of chlorine, I'll just use C. You can use whatever variables you want, guys. I'm just using these. If 5 units of chlorine is the amount needed in 550 gallons of water, find the amount needed for 850. Okay, so I have my formula. C equals K times P. And I specifically need to plug in that first part, which was the 5 units of chlorine. So the amount of chlorine, so the 5 is going to equal K times P, which is the size of water. So that's the 550 gallons of water that's needed for that swimming pool. Okay, so I'm going to go ahead and try to solve it. I'm going to divide both sides by 550. So K is going to equal, let me see, if I plug it in my calculator, I'm going to get a decimal. I know I'm probably going to ask you guys to write this as a fraction, so let's make this 1 over 110, because you can divide that by 5. So my formula that I can use, which I'll probably ask on a test or quiz, is C equals 1 over 110 P. If you want to put it as, and you don't have to write this, C equals P over 110, that will definitely work. And if you're like, wait, Miss Tapia, this said it was a direct variation. It is a direct variation. Remember, this says we're going to multiply. I told you before, this K value can be a fraction. If we're multiplying it, it's okay. You will still get credit for this. Okay, and the last thing that I need to find is the amount of water needed for 850 gallons of water. Okay, so let me use the formula that I had. So C equals 1 over 110 times P. And if I'm finding the amount needed for 850 gallons of water, that 850 is P. That's the size of the pool. So 1 over 110 times 850. So that means C is going to equal 850 divided by 110. Let me take that and divide it. This one will give you a decimal, so it should be okay for you to write it. If not, you can definitely just leave it as 85 over 11 because I don't think you can simplify 85 over 11. This is approximately 7.73. And this is units. C, yeah, because it says units. Okay, I was thinking that I didn't have any, but I do. So C is units. That's my answer. Even though we didn't do question number 2, I want us to at least label what you think it is so when you come back to it later, you know what type of problem it is. So reading that first sentence, the time required to travel a distance varies inversely with as the speed of travel. When you see inversely, this is an indirect or inverse variation. I could have put it as IV, but you guys might have thought I was crazy. Okay, for the next one, for number 3, this one is asking for you to, the power is in watts of an electric current, varies jointly as a resistance and the square of the current. For a 600 watt microwave oven, it draws a current of 5.0 amps and a resistance of 24 ohms. What is the resistance of a 200 watt refrigerator that draws a current of 1.7 amps? Okay, first, this is a joint variation question. So I'm going to put over here JV, not the team, but joint variation. And under joint variation, I'm going to first find out what my equation should be. Actually, let me zoom out a bit. So it says the power in watts. Okay, so we're going to say the power in watts is going to be W. It's going to vary jointly as, so K times, and we're going to equal K times. We're going to do it with the resistance and the square of your current. So the square of your current means we're going to take the current and square it. So this is my formula. So I'm going to zoom in on my page. W is going to equal K times R times C squared. Okay, well, based on what the direction said, it said for a 600 watt microwave, 600 watts, okay, we need to find it. The resistance in that is 24 ohms. And the current is 5.0. We're going to square that. Let's solve. So we have 600 equals K. 24 times 5 squared. Okay, so I'm going to have 24 times 5 squared, which is just 25. 25 times 24 is going to give me 600. So 600 is going to equal 600K. From there, I'll just divide both sides by 600. So my K value is going to equal 1. Well, since my K value is 1, I can plug that in for this guy and find the last bit for my question. So the last bit for my question, I'm going to use W equals 1 RC squared. You don't have to put the 1 there, so you can just put it as RC squared. That will work. And I'm going to actually find my answer. What is the resistance? So what is R? When the watt is 200, I need to find R, and the current is 1.7. Okay, well, 1.7 squared is going to be 2.89. 2.89. And then I can divide both sides by 2.89. 2.89. So R is going to equal 200 divided by 2.89. That is going to give me 69.20. And we'll write that in ohms. So this one does give me units. So resistance is measured in ohms. That's my answer. Let me highlight this one too. And let's look at the last question. I'm not going to go through the last question, but I at least want to give you what your type of variation is so you know what to do later. Okay, the last question. The illumination in luxes, I hope that's right, luxes of a surface varies inversely with the square of the distance in meters from the light source to a surface. Okay, for this one, it doesn't seem like much. I'm not seeing multiple things. I was thinking it could be a combined variation, but I'm not seeing anything else that's combining with it. Even though it says from a light source, that light source is talking about the exact same variable. It's still talking about your distance. So that distance is from the light source. So keep that in mind. This is not a combined variation. This is a basic inverse variation, which I'm going to put as IV. The questions that I didn't go over in here, make sure you actually try them. The more practice you get, the better you'll get at this.